Let's start with the gold on-demand flow. This is where Lineage helps developers instantly fix vulnerable open-source packages without breaking builds. Here's what we'll cover. First, a package in use gets flagged by AppSec. We dig in to find where the vulnerability really is, usually in a dependency. Then we create a gold version on demand. Use autofix to pull it straight from the Lineage artifact tree. And finally, compare before and after to see how the critical vulnerabilities drop to zero while everything stays compatible. I'm a developer using a popular reverse image search package, TinEye. Our AppSec team just flagged it in my dependency list. So I'm going to use Lineage to see what's going on. It looks like there's a critical vulnerability in the package. Let's take a deeper look. The vulnerability is present in a direct dependency of TinEye. Thankfully, I can create a new golden version of TinEye by patching this vulnerability using Lineage's auto-fix capability. The fix is fully compatible, so it won't break my build. Lineage patches the dependency safely and keeps the same APIs and behavior intact. I'll click on Autofix, and Lineage automatically starts creating a new branch in my GitHub repo. It replaces the vulnerable dependency with the clean, compatible one. Lineage raises a pull request showing the change. The package is now sourced from the Lineage Gold artifact tree, fully verified and traceable. Here's the manifest diff, just one simple line updated. No code changes, no functionality impact. It's the same TinEye package, just securely sourced. Before, the package had a critical vulnerability. After applying the gold version, all critical vulnerabilities are gone.
Now let's move to containers. We'll look at a Rachel UBI 9.2 micro image that's been flagged as vulnerable. Here, Lineage's policy-driven autofix takes over, automatically remediating anything that violates policy. Here's the flow we'll walk through. First, we'll review the UBI 9.2 micro image and see what's inside. Then we'll look at the vulnerabilities Lineage detects. Next, you'll see how fixes are applied automatically based on policy. And finally, we'll view the post-fix image, which is now free of high vulnerabilities. We're now looking at the Lineage scan for the RHEL UBI 9.2 microcontainer image. This image is vulnerable, and the goal is to fix it automatically based on our policy. Lineage will decide what gets fixed according to the rules set by our AppSec team. Now let's go to the Vulnerabilities tab to get more details. We can see that there are 8 high vulnerabilities. Let's click on the Findings tab to review the policies and their violations. Our AppSec team has set a critical policy of no exploitable, critical, or high vulnerabilities. We can also define additional policies across the 108 attributes we collect. Let's create a plan to remediate our exploitable, critical, and high vulnerabilities. We offer 3 plans: compatible, minor, and major. Compatible, which fixes the vulnerability while guaranteeing build stability. We can see the selected compatible fix versions that were suggested by Lineage AI. Click on Autofix to trigger our AI fix bots. Here we can see the AI bots mimicking a developer workflow, from raising a Jira ticket to actually entering the commands to patch the image. The Compare agent gives us a full diff view between the 2 projects, showing that the vulnerabilities went down in the new image we just created.
Using Lineage, we brought down vulnerabilities across both packages and containers automatically, and without breaking builds. The Gold on-demand flow cleaned up our open-source dependency, and the policy-driven autofix kept our container image compliant. One unified workflow, end-to-end visibility, and 0 manual effort. That's how Lineage keep builds secure and production ready.